Hello and welcome. Today, the topic of the tutorial is on deepfake generation and detection. Let me first introduce ourselves. My name is Siwei. I'm currently a professor in the Department of Computer Science and Engineering at the University at Buffalo, State University of New York. Previously, from 2008 to 2020, I was an assistant, then associate, and then full professor at the Department of Computer Science, University at Albany, State University of New York. Before that, 2005 to 2008, I was a postdoc at New York University and Howard Hughes Medical Institute. I got my PhD degree in computer science from Dartmouth College in 2005, and my master's degree also in computer science and technology from Peking University in 2000. I got my bachelor degree in information science from Peking University also in 1997. I'm a recipient of the NSF Career Award, IEEE Signal Processing Society Best Paper Award, and a Google Faculty Research Award. My main research interest is in multimedia, forensics, computer vision, and machine learning. My co-presenter today is Dr. Yuezun Li. Yuezun is currently a lecturer at the Department of Computer Science and Technology in China Ocean University. Before that, Yuezun was a postdoc at the University at the Buffalo State University of New York from 2020 to 2021 with me as his supervisor. And even before that, Yuezun got his PhD in computer science from University at the Albany State University of New York, with me being his dissertation advisor. He got his master's degree in computer science in Shandong University in 2015, and his bachelor degree in software engineering, also from Shandong University in 2012. Yuezun's main research interest is in multimedia forensics and computer vision. All right, so in today's tutorial, we'll cover the major topics about deepfakes. Here is an outline of our tutorial. In the first part of the tutorial, we'll talk about what are deepfakes, and I will lead that discussion here. And the second part will focus on generation of deepfakes. The third part will spend fair amount of time to give a comprehensive coverage of the existing deepfake detection algorithms and data sets. And Yuezun will take that part. And after that, we'll talk about how to get an upper hand on deepfakes, which means instead of passively detecting deepfake videos, can we do something, turn the table around on deepfake generators and be more active and probably proactive? Last, we'll have a wrap up, some future perspectives on deepfakes, and to give also some higher level perspectives on the future of the research on deepfake detection. All right, so let's get started. So what are deepfakes? Well, deepfakes are just fake media created with the help of deep learning. Now, falsifying media is not something new at all. Actually, we started to manipulate photographs even at the infancy of photography as a technology itself. So in the early 19th century, we already have known examples of photographs being manipulated. Then everything got changed significantly with the advent of computers and digital images. And now we have Photoshops and we have computer graphic softwares, which make creation and manipulation of digital images or photographs way much easier and save time and lower the requirement on expertise. And we can also manipulate videos. So like the famous, this is a kind of a common practice in Hollywood. Like some of the big budget movies, like Forrest Gump, I shown here, with this kind of manipulation, manipulation technologies being used there to replace the actor into the scenes of a movie. But so, what have been changed? Well, with the advent of AI technology and the internet, we are making fake, we have the capacity of making fake media at a whole new level, right? In my opinion, there are four important factors that improve significantly our ability to make media forgeries. The first one is the widespread of social platforms, including Facebooks, Instagrams, WeChats, Twitter, TikTok, and so on, YouTube's, right? So this on the social platforms, people share their personal data, their images, their imagery, videos, audios, and at the same time, once somebody created a fake media, they can spread much faster on the social platform. The second component, I think, is coming with the computation power, especially those graphical processing units or GPUs. The advance of GPUs has made the computation to multiply exponentially, and we are seeing a lot more computing powers at our hands these days. And this is one of the major driving force that make the recent advances in AI technology, especially deep learning, as well as in creating fake media. The third part component, of course, is the fundamental technology advance in artificial intelligence, and particularly deep learning or learning with deep neural networks. And then also the kind of wider spread of the culture of open source, make it much easier for someone to implement a particular media synthesis or manipulation tools and put it on open source platforms, code sharing platforms like GitHub's. So more people potentially have access to these tools and start making fake media. So putting all four factors together, we're seeing a huge surge of AI synthesized fake media. So putting deep learning and fake media together, we got deepfakes. Okay, and deepfakes comes with many different forms. For instance, we're seeing faces corresponding to persons who do not exist. All these faces look very realistic, but they are not real people. These faces are actually created using AI, using AI tools, using deep neural network models. To be more specific, the GAN models. Okay. These kind of synthesized images have found uses as the profile images for fake social accounts on social platforms like Twitter, LinkedIn, and Instagram. Last year alone, these companies have identified more than 4,000 such accounts on their platforms. And as you can see, an example here, the fake account actually have got connections from real members, users from those social platforms. Not only faces can be synthesized, we also can hear speeches that were not actually spoken. So let's hear an example that is generated in my lab.
Today, I'd like to overview the exciting field of deep reinforcement learning, introduce, overview, and provide you some of the basics. I think it's one of the most exciting fields in artificial intelligence. It's marrying the power and the ability of deep neural networks to represent and comprehend the world with the...
So you probably have heard former U.S. President Barack Obama's voices But he is talking about deep reinforcement learning, which is more likely a topic that he never talked about. So actually, this whole speech was synthesized using an algorithm, and the algorithm is called voice conversion. Basically, represent um, the same speech using a particular person's voice, impersonating a person's voice. So again, this kind of technology has also found some malicious use recently. One of the recent reports have shown that a scammer actually successfully used a voice synthesized using algorithms to cheat a company CEO to actually make an employee in that company to wire transfer more than $200,000. So this is one of the first examples that fake media actually cause real world financial damages. We're also seeing images where the subject's face are changed. So what I'm showing you here, probably you recognize the face on the left. That's the real person, real actor, Brad Pitt. However, the four other videos on the right, you may recognize those are for different people. Indeed, all the four videos on the right-hand side were created by swapping Brad Pitt's face with some other people's faces and keep the same facial expression as the original person. So this kind of videos are usually known as face swap videos. And this kind of videos are actually also causing some unpleasant social impacts. There is one phenomenon known as revenge pornography, where people can actually plant faces of their ex-spouse or ex-girlfriend. Mostly in these cases, the victims are women, and and into a pornographic video, and then post such videos on social platforms. And spread of that kind of videos actually cause huge psychological trauma to the victims. And there have been quite a few cases in the US that this is actually leading to psychological, emotional damage to the victims. This kind of videos can also sneak into politics, okay? And you can imagine some politician who will say something that's actually not indeed said by that person, and the kind of chaos and confusion that will cause for the communities. Based on an incomplete report from Sensitivity.ai, which is a nonprofit organization monitoring the trends of this kind of face swapping deepfake videos, it seems that for every 6 months, the number of online fake videos double in sizes. I think this is an underestimate. We are going to see a lot more of this, and there probably more exist online. But this already showed that how easy, how widespread this kind of videos can be. The most sophisticated form of deepfakes are those combined audio and video cues together. So what I'm showing you here is one example that was made by researchers from MIT and Scientific American. The background is that this was for US President Richard Nixon in the 1960s when the Apollo project to sending astronauts to land on the moon. At the time, the government prepared two documents for Nixon to read out, one for a success and the other for failure. Of course, we know the success story, but the failure document was actually never read. So the MIT and Scientific American researchers actually found out that document, and then they use AI technology, generating those deepfakes, creating or recreating the presence of President Nixon read out the message in case the moon landing was a failure. Let's see.
Every human being who looks up at the moon in the nights to come will know that there is some corner of another world that is forever man.
So, as you can see, the result is quite appealing, quite convincing. Even though this video, this lecture, this video never exists, this actual talk never exists, it creates the illusion that it actually happened. The most recent developments in deepfake generation is to push the limits to real-time production. There is a software on GitHub known as Avatarify that can create live deepfake audio and video streams that can be used on Zoom or Skype calls. Now, this causes one additional problem for our society. Just think about a teenager, a young child who's supposed to talk with family members or friends remotely over Zoom or Skype, and it turns out that it was a predator behind all these conversations, but masqueraded as those family members and friends. So that kind of consequences is something we really do not want to see. Okay. So deepfakes has become recently a very popular and hot topic for media. But what's the history of deepfakes? How we ends up in this situation? Well, first, deepfakes first landed on everybody's radar in late 2017 when there was a Reddit user with the account name DeepFakes started to share face swapping pornographic videos online. And this was captured by a journalist. And in late 2017, December of 2017, the first news report on this new technological development was reported and immediately caught everybody's attention. This method used by the Reddit user was actually originated from an earlier paper in the same year in NeurIPS 2017 from a research group in a media research lab using unsupervised image-to-image translation networks to transfer the style of images. So the original application is quite innocuous. You can see that the examples from the paper, they actually take an input image of a daylight scene and convert it into night scene or vice versa. However, this algorithm was adapted by this Reddit user and for the purpose of generating those kind of fake pornographic videos. Actually, manipulating human faces in videos using machine learning algorithms is not a new idea. One of the earliest paper can be traced back to the year 1997 when we seen the paper, a method work known as video rewrite by Chris Bragler and collaborators, where they started experimenting using audio signals to drive synthesis of visual frames in a video. The difference is back those days, machine learning is fairly primitive, and it is not a lot of, we do not have the machinery to actually take advantage of the large collection of data we have. So the quality and easiness of creating this kind of fake media back then was not comparable. But ever since the first deepfake sold around, this got a lot of interest, and we start to see many open source tools making deepfakes. And also on the internet, we start to see a large number of face swapping videos surfaced on social platforms and challenging our ability to tell them apart from the original ones. On a different line of development, the GAN models that were used to synthesize highly realistic human faces started with the work of Ian Goodfellow and collaborators in 2015, 2014. So once the GAN model, the GAN model was known to the research community, it raised a lot of interest, in particular to synthesize realistic-looking human faces. And you can see the sequence of quality of face images generated by different generations of GAN models and see how quickly we have changed the quality of those synthetic images, starting from something that is low resolution, monocolor, all the way to full-blown 1024 by 1024, high resolution, highly realistic human faces with the most state-of-art face synthesis algorithm known as StelGAN, also come from NVIDIA research group. And the audio deepfake synthesis didn't lag far behind any either. There are actually quite a few works in this area, but I think the most notable example is from the company, Montreal-based company known as Lyrebird.ai. So they actually provide this personalized voice conversion based on AI algorithm, deep learning algorithms that claim to be able to impersonate anybody's voices. So this audio deepfake synthesis technology is also becoming mainstream in the recent years. So why are deepfakes harmful? Well, first of all, as we have seen a few examples I laid out in the previous slides. They cause real damages. Either this is revenge pornography, or a changed, an altered political message, or a real-time Zoom call with someone masqueraded as another person. They will lead to some very negative societal impacts, results. Secondly, one of the most alarming side of this is they're now very easy to make, because the existence of all this software, free open source software tools, as well as the GPUs, high performance computer servers becomes a commodity, and also the abundance of data on social platforms we're sharing. So it significantly lowered the threshold for someone who want to create this kind of fake videos to use these tools and data and the computation platforms. But I think fundamentally, the most significant danger that this kind of fake media poses to us is they erode our trust of online media and the information. Because they implanted the idea that information can be manipulated, can be falsified, then we start becomes untrustful for all the images, videos, and audios we experience on the social platforms, on the internet. And I think this is causing the biggest problem, as it's against the very initial motivation of developing the internet, which aims to improve the flow and spread of information. So we should definitely take this problem seriously. But deepfake technology by itself is not about good and evil. Indeed, it is like any other technology, like DNA, human genetics, or nuclear technology. It largely depends on who uses it and for what purpose. The same technology can also have some beneficial uses. Here, I just point out two examples. For instance, this kind of technology can be used to de-identify a person for protection, a victim or a whistleblower from exposing his or her identities to the outside world. The other beneficial uses, which we recent years have seen quite a few examples, is in movie industry, with this kind of technology, we can reduce cost and probably also reduce the production time and make a realistic movie, like in this case, for an actor to play a younger version of himself or herself, or some actors who have already deceased to be recasted on the big screen. So we need to keep this beneficial benefits of technology in mind, but at the same time, be aware of the high social negative social impact this technology can have to our lives. The potential negative social impacts of deepfakes have also caught attention from the governments. For instance, the US Congress have two hearings on this topic in the summer of 2019, roughly 1 year after deepfakes became a social phenomenon. The US Congress actually take this very seriously, and several bills have passed on this topic, aiming to regulate the use of deepfakes, in particular those forms, malicious forms of deepfakes, and control their potential negative impacts. These similar legislative efforts also occurred at the local level, state and local level in the US, as well as in several other foreign countries. Also, the attention to deepfakes increase research programs and funding projects from both the government and the commercial companies to this topic. The most notable examples are the DARPA in the US have two programs, one on media forensics, one is called media forensics, the other called semantic forensics. Media forensics started from the year of 2016 all the way to 2020. And the semantic forensics program started from 2020 all the way to 2024. Both programs aim to improve our capacity to detect fake media and mitigate their negative effects. From the commercial side, earlier last year in 2020, Facebook led a group of companies and nonprofit organizations started a global deepfake detection challenge on Kaggle. And that one is a study of the state of art, reflects the state of art of the current deepfake detection algorithms and based on a large data set of fake videos. Correspondingly, the number of research papers on this topic increases very fast in recent years. Previously, it was only in the relatively small sub-community of multimedia forensics in signal processing. And in recent years, we start to see papers on this topic show up in major computer vision conferences like CVPR, ECCV, and ICCV. The development of detection and mitigation technology of deepfakes rely on the availability of large-scale data sets. Actually, in recent years, we have seen many deepfake data sets being provided to the research community. Some of these data sets include large number of high-quality deepfake media. One example I highlighted here is the CelebDF dataset, which is a large-scale, high-quality dataset for high-quality face swapping deepfake videos. So the existence of this large-scale datasets is hugely helpful for the development and evaluation of the deepfake detection and mitigation methods that we will talk about in detail subsequently. But before that, let me first briefly overview the existing generation technology of deepfakes. For this part of the tutorial, I will briefly overview existing technologies to create deepfakes. Now, there is a huge literature on this topic, so within the time limit, I cannot go over every existing methods creating deepfakes. So what I will do is give a high-level overview of the general technologies that we can use to create fake media using AI technology, using deep learning algorithms, and then just sample a few representative examples to go into some details. All right, so we talk about deepfake generations. There are, for different kind of media, there are different generation algorithms. So we will take a look at different media types, including images, videos, and audios. Starting with videos, we have the first type of, one common type of deepfake videos is what they call face puppetry. In this case, as the example shown here, we have an input video, which is one subject, and we are using algorithm to generate an output video of a target person that is generated using this model and have the same facial expression and head movement as the input video. So this is, in some sense, this is called a very similar idea to a puppet. Okay, and notice in this case that it is not just a part of the face that is being synthesized; it's actually the whole face and upper body. In this case, are created using the algorithms. The next type of video deepfakes is face swapping, as we have seen in previous examples, where we only use algorithm to replace the face part of the input video. Okay, and the third part is the lip syncing. This time we create a video, but we only use algorithm to generate the part that the lips moves, so that the subject will talk, will give a speech from a previously existing text. Okay, so you can view this as a combination of face synthesis and audio synthesis, voice synthesis. For images, we have whole face synthesis, as I've seen using GAN models. Another type of face image synthesis is to edit specific attributes of faces. This includes the facial expression, age, gender, hairstyle, facial hair, and so on. This works as one example of this kind of works is shown here, as you can see the subject's facial expression and also facial hairstyle being changed using algorithms. There are two common tasks for audio deepfake synthesis. The first one is called voice conversion. In this case, we have two speakers, more than two speakers, and we want to change a sentence spoken by one speaker to the voice of a different speaker for the same sentence, but with different voices. The second task is called personalized text-to-speech synthesis, or TTS. In this case, we have as input a text sentence, a sentence in text, and then the system is going to convert this into the waveform, into the voice of a given speaker. Okay. In the following, we will just take a few examples of these models and give you some idea how deepfakes are created. So let's start with face swapping video. Okay, the general flow of the general pipeline of the generation process starts with an input video. So this is the input original video. The first step is to run a face detection and alignment algorithms on each frame of the input video. And we can then crop out faces in the original video and align them to standard configuration. After that, this input sequence of cropped faces will be sent into this generation model. The whole purpose of the generation model is to create a sequence of faces corresponding to a different subject, but have exactly the same facial expressions. So this is achieved with a model known as the autoencoders. So the autoencoders are actually formed by a pair of deep neural networks. One is known as the encoder, the other is known as the decoder, okay? The encoder's job is take the input face and convert it into a code. And this code corresponding to the facial expressions in the input sequence. It is the decoder's job to then take the code and reconstruct another image of another faces of another person, keeping those essential facial expressions. Now, the way to understand how this works is to make analogy with language translation. Suppose you want to translate a sentence in English to a different language, say Chinese. The way to do that is we first separate the language and the message itself, right? And then we only keep the message and then recast the message into a different language, in this case, Chinese. So a similar process can be used to understand the working mechanism of an autoencoder here. What the encoder does is take the input sequence of faces and hypothetically assume that's a language, assume that's making an analogy to the language translation scenario, the identity of the person corresponding to the language, while the essential facial expression corresponding to the message. So the encoder basically discard the language, in this case, the original person's face identity, and keep the essential message, which are the facial expressions. And then the decoder's job is simply recombine that facial expression, that message, with a different language. In this case, cast it into a different person, generate faces of a different person, keeping the same facial expression. Now, both encoder and decoders are deep neural networks, convolutional neural networks, and they were formed by several layers of artificial neurons, which are basic computation modules simulating the work of a biological neuron. It's an oversimplified model of biological neurons. Now, once we go through this process, we can create the faces of the target with the same facial expression. Then the next step is to creating a mask where only the essential part of the face is being kept, and we get rid of all the surrounding parts. And then when we put that separated face back, paste it back into the original video, with some post-processing, smoothing the boundaries, we can get a good quality face swapping video. Okay, so that's how an autoencoder model helps to generate face swap videos. Now, the autoencoder, the encoder and decoder in the autoencoder model need to be obtained using training data. So the general idea is we get training data. We need the training data in the form of faces of the targets, the source and targets we want to swap face with. And the trick here is to form two different encoder-decoder pairs. We want the two subjects to share the same encoder and then have their individual decoders. The reason for that is to make the encoder to recognize something in common between the two subjects. In this case, they are facial expressions. And training just happened as forming the encoder-decoder pair and compare the differences between the input images, input face images, and the reconstructed ones. So typically, we use L1 or L2 reconstruction losses, okay? And training just keep running. We just keep tweaking the parameters in the neural networks of encoder and decoder until the input and the reconstructed images become quite similar. Now, this is the most time-consuming part of creating deepfakes, face swapping videos. So usually we need a GPU to help us Just running on CPU will be too slow. But you can see that as the model, so what I'm showing you here is a video of faces that are created using a particular encoder-decoder pair. So at the very beginning, you can see that the face is very blurry and there's not so many details of the face shown up. But as the training progressed, more and more facial details showed up, and the face starting to look realistic and convincing. But this process has been, so to create this video, I accelerate the whole process by 5,000 times because the typical training time for this kind of models will be on the level of days. But nevertheless, the whole process is automated, right? What left for the user to do is just to collect the training data, have a piece of the software for the training, and then run this on a computer equipped with GPU for some time. Once the model is trained, the user can start to use the model to making new fake videos. Now, that's autoencoder model for face swapping videos. Let's now switch to GAN models for face synthesis. In this case, we need another neural network model that is known as the generator. So the job of the generator is to take a random noise as input. This is typically known also as the latent code, and go through these neural networks and create a synthetic face image. But what differs the GAN model from the typical neural network model is it also needs another counterpart. In this case, it's called the decoder. The generator is usually, again, complicated neural network model, a convolutional neural network model with several components. In the particular case of style GAN model, it is actually formed by a front end and the later end of convolutional neural networks. The decoder, on the other hand, is also a deep neural network. In this case, it's used as a classifier. Okay, so the way a GAN model works is whenever there is a real face, go through the discriminator. The discriminator is trying to make the decision whether this image is real or fake. And training just happened as a game, as a competition between the generator and the discriminator. So the generator is trying to create more realistic face images so as to confuse the discriminator, that the discriminator cannot tell the difference between a real face and a synthesized face. On the other hand, at the same time, the discriminator also trying to improve itself so that it can have better capacity to tell the differences between real faces and those fake faces created from the generator. So the two models play this game against each other, and the training will stop until both of them reach an equilibrium, and they cannot go any further. So, so that's the unique training mechanism for GAN models. And turns out that this type of models have a huge advantage when learning complicated data structures like human faces in high dimensional space. Most recent GAN models like the StelGAN 2 model also uses a multi-scale strategy where they started building smaller crude models. And after the low resolution model is completely learned, they build on additional layers so that the image resolution will improve until to the level that is satisfactory in this case 1024 by 1024. Okay. Now for the audio deepfakes, typically we rely on sequential models, because audio is a 1D, usually is treated as a 1D sequential signal. In these cases, the most, for text-to-speech synthesis, the most successful model these days is, one of the most successful models is known as Tacotron 2. And its basic flow is like this, with the input text is first embedded into a latent space using the text embedding module. The text itself is sequential, so this text embedding model involves bilateral, bidirectional LSTM as a sequential extraction model. And then the text, embedded text, is used to help to create the spectrogram of a sound. Now, the spectrogram is just a time frequency representation of the 1D sound signal. And once we have the spectrogram created using other modules of RNNs, LSTMs, the spectrogram will be sent into a vocoder. In this case, we use, in the case of Tacotron 2, a WaveNet vocoder is used, which itself is a huge RNN sequential model. And after that, we can generate the sound waveforms. For the other tasks of audio deepfake synthesis, voice conversion, one of the popular ideas is actually reuse the strategy of the video deepfake models. But in this case, face swapping deepfake video generation mechanisms. So the idea is to use autoencoders in this case. We first take a first person A's speech in their spectrogram representation, and then just treat this as a style transfer problem. Keep the sentence, the contents of the sentence, and change the representation to a different person's voice, also in spectrogram. Now, once we have this spectrogram encoder and decoder trained in a similar way as the face swapping video generation, we can then attach this with another vocoder. We have a lot of choices. We can use WaveNet. We can also use Mailgun and some other type of vocoders. And the vocoder's job is actually convert the spectrogram into the waveforms. So this whole model can be made end to end, and with enough number of training samples, we can get fairly reliable deepfake detection, audio deepfake synthesis models. So this is a quick overview of deepfake generation methods. Now, the more important question is, if we have a piece of deepfake signals, like images, audios, or videos, how can we detect, how can we make sure, how can we be certain, how can we determine their origin, whether this is real or created from an AI algorithm? This is the topic of detecting deepfakes, and Yuezun gonna take over.